Welcome back to the shop and to the channel. In a previous video I was using this footstock along with the dividing head to mill a test piece for a shaft I need to make, and I had a heck of a time trying to get these two pieces lined up. And I think it's because these keys here aren't really made for the wider slot of the K&T table. Of course, these keys here are made to index into the slot so that you get a perfectly aligned piece of tooling. Now here in the Bridgeport table, it's a perfect fit. There's no play whatsoever. Now, of course, there's absolutely nothing wrong with these keys, and when I'm using this tooling on the Bridgeport, I'll need to put these back in. But for now, I'm going to go ahead and take them out. I'm going to take some measurements, and I think we're going to go ahead and mill up some new keys for this footstock and the dividing head that will better fit the table slots on the Kearney Trecker. Just want to try to clean as much of the gunk out of this slot as I can, and I think I'm going to use a set of gauge blocks to see if I can't get an accurate dimension. Now, these gauge blocks aren't in the greatest condition, so they might be off a little bit here and there, but I think they'll be plenty accurate. And this stack here is 686 thousandths and 9/10, so just shy of 687 thousandths. I'll do the same thing here on the slots of the Kearney Trecker table, and this stack of gauge blocks is 685 thousandths and 9/10, so about a thousandth of an inch narrower than the slots in the bottom of the footstock. Well, I had the same issue with the dividing head. It was just really sloppy in the slots of the Kearney Trecker. Again, nice and tight on the Bridgeport. So when I'm using this on the Bridgeport, if I do need to use it on the Bridgeport, I will certainly keep these keys handy and put them back in. But for now, we'll take them out and use some gauge blocks again to measure the width of the slot. So we got another stack of gauge blocks here, and these come to 687 thousandths and 5/10. So about a half of a thousandths wider than what's in the footstock, and almost 2 thousandths wider than the slot in the table. I dug around in the scrap bin for a bit and came up with this piece of material. I don't know what kind of metal it is. And it's a bit oversized for what I need, but I will get 4 keys out of this, 2 for the dividing head and 2 for the footstock. Well, as usual, the first order of business is going to be mounting this in the vise so we can get all of the sides square. I am going to try a slightly different approach to square this up than what I usually do. Usually I will square one side and then rotate it to square up all 4 sides. But this time I think I'm going to try to do the 5-face method, where I will machine the top and then the 4 sides around it so they'll be square to the top. But I also want to use this opportunity to try to get the width down to where I want it. So in order to do that, I need to find the center of the y-axis. So I've got the center edge finder rather in the mill, and I'm just trying to find the center of this piece before I start machining. The first order of business now is to go ahead and machine the top of this flat. So I've got this 1.5 index face mill in the quill, and we'll go ahead and touch off and then just take 20 thousandths or so off the top to clean off the rust. I would normally use some kind of cutting oil here, but I'm going to try something a little bit different. I've been using anchor lube for quite a while for drilling and tapping, and I know it can be used with milling operations as well. Now, I probably put way too much here on the top of this thing. I don't think it needed to be that thick. But what I like about anchor lube is it doesn't smoke. It's water-based, so I have to be a little bit careful of where it ends up. But it keeps the part cool. It keeps the cutting tool cooler. And just the fact that it doesn't smoke and it doesn't stink is a huge plus to me. The other thing I like about Anchor Lube and using it is I'm supporting a local company. Anchor Lube is made right here in Northeast Ohio. They're maybe 30 minutes or so from where I lived, so I don't mind supporting them and using this product. It works well for drilling and tapping. It's my go-to tapping lubricant, but this is the first time I've actually tried it as like a cutting oil. If you'd like to give Anchor Lube a try, and I think you should, there's a link down in the description that takes you to their Amazon store. It's not an affiliate link. It could just go straight to their store, and you can pick up a bottle of this. They sell it in a few different sizes. With the surface nice and flat, I can go ahead and take this out and we'll replace this with a 4-flute carbide end mill. Well, with this solid carbide end mill now in the quill, we'll touch off and we'll start machining off this front edge. With the front edge machined square to the top, I'll go ahead and touch off on this right side and machine off a few thousandths to get it square and cleaned up. Now to machine the back edge, I offset the quill the exact distance that I was offset from the Y center of this part, meaning when I finish this pass here, the part should be parallel, both sides should be parallel, and they should be the exact distance from the center where I set the 0. Well, in my head, all of that made sense, so I hope it did to you. And it looks like I didn't clean all the gear marking compound out of that paintbrush I'm using, because there's a little bit of yellow here mixed in with that green anchor lube. Well, with the first 5 sides being clean and square to each other, we'll take it out of the vise, I'll deburr it, and then we'll flip it around and set it back in so we can finish the top side. Well, now we'll flip this over and put a little more anchor lube on the top, this time with a cleaner brush, and we'll go ahead and take 20 or 30 thousandths off of this face before checking to see how thick it is. Use a micrometer here to check the thickness. I want to mill this down to be about 600 thousandths thick. It's pretty thick for a table key, but I want that portion of the key that fits down in the slot of the Kearney Trecker to have a lot of side-to-side purchase on that slot edge. And this will make this hopefully a little bit more secure. I could be wrong about all of that, but it's what I'm going to do anyway. So I'll just keep taking 25 to 50 thousandths off of the top of this until I've milled it to the thickness that I'm looking for. Well, if I keep putting this much anchor lube on this part to machine it, I probably should go ahead and get a gallon of it, because I'm going through more than I need to. I am just laying this on a little heavy. I don't think I need to use this much. I know you can also dilute it 1-to-1 with water, and maybe I'll do that and put some of it in a spray bottle and use that instead of making it so thick. I'll check the dimension or the thickness of this with the micrometer and see how accurate my DRO is, and I think it's pretty accurate. And it looks like we hit that 600 thousandths target spot on. Maybe, half a thousandth, less than half a thousandths over. I'll take it. Well, I have that solid carbide end mill back in the quill, and what I want to do now is machine the top 350 thousandths of this piece down to the width of the slot. I touched off probably a little bit heavy there, but now I want to raise the knee 350 thousandths. So I've got the knee up 350 thousandths. We'll go ahead and touch off, and we'll go ahead and take off 25 or 30 thousandths from the front. Now the DRO is still zeroed at the center of this part. Now as long as I've moved the quill to be the same distance away from the center to the rear that I did to the front, I should be taking off exactly the same amount of material on each side. Well, I realized using that small carbide end mill was going to take too long, so I dug around in my toolbox and found this roughing end mill, and this will at least let me take off 50 thousandths at a pass and get me a little bit closer to my target dimension a little faster. With the bulk of the material removed from each side, I'm going to take this end mill out and put the solid carbide end mill back in. Take a quick measurement here with the micrometer just to see how much further I need to go, how much more material I need to take off from the front and the back. So my target is 685 thousandths and 9 tenths. I'm currently at 708 thousandths and 4 tenths, so that's 177 and a half thousandths to go. So half of that on each of the front and the back still needs to come off. Use a file to deburr these corners so I can get my micrometer in here and take an accurate measurement. This doesn't look good at all because I was targeting 685.9 and I'm at 671. So somewhere I did something wrong. And sure enough, this is looser than I want it to be in the slot. It might be fine for some, but I was going for a really nice tight fit, so I have to start over.
One eternity later.
Well, after finding some more stock and milling it to this point, I looks like I'm really close to that target dimension. We'll go ahead and check it in the mill table to see how well it fits. So we'll take it over here to the Kearney Trecker, and that's exactly how I wanted this to fit. It takes just a little bit of pressure to get it into the slot, and there is absolutely zero side-to-side play. So that's perfect. That's what I was looking for. Not sure what I did on that last piece, but oh well. Move on. Make mistakes, learn from them, move on. Well, with the bottom portion of this milled correctly for the table slot after a failed attempt, I need to go ahead and cut this in half because the tops of these are going to be machined just a slightly different width than the other. We'll go ahead and score a line here so we know where to cut it. I could have probably kept this together for a little while longer, but this is what I ended up doing. The slots in the dividing head and the footstock being slightly different, I don't want to get these mixed up, so I'm going to use a Sharpie here just to mark on here temporarily which one is which. And this is where I could have kept those pieces together a little bit longer. I'm going to machine the top of these down just a little bit to get this thickness a little bit closer to what I wanted. And had I left it together, it would have been no different than what I'm doing now. Really, it's just that there's a space in between the two pieces. With the top of this now milled down to the thickness that I wanted, we'll go ahead and take them out and deburr them and get ready for the next process. I have the part that's intended for the footstock now back into the vise. We'll go ahead and start machining off the width of this to fit that slot in the footstock. I am going to be doing this, however, a little bit differently than what I did to machine the side that goes into the table slot. Well, I'll start here by touching off on the front face, and we'll dial in 50 thousandths to come off this side. And rather than move the saddle to put the cutter on the other side of this part, I think what I'm going to do is remove it from the vise and flip it 180 degrees. And that way I'm guaranteed that I am taking off exactly the same material on the front as I am the back. Now do a quick deburr on these top edges so I can get an accurate measurement with the micrometer. So my target is 686 and 9/10, but I'm measuring 851 and 7/10. So we'll go ahead and subtract the one from the other, and that will give me how much that needs to come off overall on the overall thickness. Divide that number in half, and I've got to take 82 thousandths and 4/10 off of each side. Now what I'm going to do now is put that number in my DRO. And as I whittle down on these faces, I'm going to be closer and closer to 0, and when I get to 0, I should be right on dimension. And as long as I remember to flip the part each time to take the same off of the front and the back, I should end up with a perfectly symmetrical key. And when I put it in these tools, that I should be lined up perfectly with that slot each and every time. And even though I think I can rely on the DRO to be accurate, I'm still going to periodically stop, deburr, and take a measurement with the micrometer just to make sure I'm not off on my math. Well, I'm not at my target dimension that I've calculated, but I do want to take it out, measure it, and then also check it in the footstock just to see that I'm going in the right direction and I haven't gone too far. Yeah, not quite fitting yet, probably about 10 thousandths off, which is exactly what the DRO is telling me I still need to go. Well, the DRO tells me I'm on dimension, but this is still a little bit tight in here. So I've got a little stone here. I want to make sure that I get rid of any burrs that are in this slot. There are a few, and I think that's why it's still a little sticky in just part of the slot. Most of the burrs out of there. Let's give it a test. It starts to go in, but then it gets a little bit tight here in the center. And even though that's not an important part of the slot, the key isn't going to be there. I'm going to go ahead and try to clean this up just a little bit more. And that fits in there perfectly. There's no side-to-side play. It's a very nice, snug, I don't know what you call that, a machinist fit, interference fit. I don't think it's an interference fit. Correct me in the comments. I'm not sure what you would call this, but it is perfect in my book. Well, the operations for machining the key for the dividing head were the exact same as for the footstock, the only difference being the dimension, and we've got this now nice, tight, snug fit in the base of the dividing head. Well, now that we have these things sized appropriately, they need to be cut in half again because I need 2 keys for each, not one big one. So I'll mark these for approximately half of their length, and we'll take them over to the bandsaw and cut them in a more traditional fashion. While taking a cue from the keys that I removed from the dividing head and the footstock, I'm going to mark these for the Kearney Trecker table, as well as which pair is for the dividing head and which pair is for the footstock. Well, there's still a couple of machining operations to go, and first up is to trim them to length. I'm going to trim them all to the same length. The first step is to clean up one side of each of the keys. Well, with one side cleaned up on all four, now I want to find which one is the shortest, and we'll use that as our starting dimension. So I'll measure one of these in 0 in the calipers, and then find the next one. And if that one's shorter, which this one is, I'll re-zero on that. And I'll just keep going until I find one that comes up as the positive. So that is also shorter, and that one's a little bit longer. So it looks like this one here will be the shortest one, and we'll use that as our starting point. Well, I've got the shortest one on the vise with another one on the back to balance it. I don't have any of those little clamp-on vise stops, so I've got this little tiny can't twist clamp. I'll put that on the top of the vise jaw and use that as an index for when I cut the other keys to length. I'll bring the end mill over and touch off on this piece, and we'll just take off 0.010 off the edge just to clean it up. Well, I'm not machining these to any specific length. I'm just going to clean up the face here on the short one. And with that one cut to length, I can put in a next key and index it up against the can't twist clamp and trim it to the same length. Well, we're getting down now to the last machining operation I need to do on each of these keys, which is to bore and counterbore the mounting hole in the center of the key. So the first thing I need to do is find the center of the key with my edge finder. Then I'll clamp on my little can't twist clamp onto the top of the vise jaw as an index for when I need to do the other three. And as I normally do, I'm starting with a 120-degree spotting bit just to spot the location for the hole. Next up is a 9/32 drill for the clearance hole for a 1/4-20 socket head cap screw. I'm going to finish drilling these clearance holes first before I come back and do the counter bore, just so I can minimize some tool changes. With all of the clearance holes drilled, I can remove the drill chuck from the spindle and I'll replace it with a 7/16 inch 4-flute end mill. I have the quill stop set to bore this out to a depth of 280 thousandths. Well, after a quick deburr over at the Baldor buffer, we can go ahead and mount these in the footstock and in the dividing head. We can go ahead and turn the dividing head now onto its bottom and fit it right in the slot. And there is no side-to-side play, which is exactly what I wanted. I'll bring over the footstock now and get it mounted in the table slot. And again, no side-to-side play, and that's exactly what I was hoping to achieve. I have a dead center mounted up in the chuck on the dividing head, and it might be hard to tell from the video, but the dead center that's in the footstock is really, really close on alignment. It's spot on from a horizontally, but vertically it might be off a little bit, but that'll be easy enough to correct when I go to use this. Well, that's it for this little side project and this video. I hope you enjoyed it, and if you did, please give me a thumbs up on the video. It really helps with the YouTube algorithms. Leave me a comment. Let me know what you think. Is there something I could have done different, done better? I have other keys to make for other bits of tooling, so anywhere I can improve is always a bonus. Again, I'd like to thank everyone who has subscribed to the channel. If you're not a subscriber, I'd appreciate it if you would hit that subscribe button. It doesn't cost you anything, and if you hit that bell icon, you'll be notified whenever I post a new video. Well, that's it for this week. Thanks for watching, and we'll see you on the next one.